So we'll be writing here. Now in the velocity, as we have seen with the speed also, the velocity can be average velocity or instantaneous velocity, right?
Well, for both the formula will be same.
Yeah, the formula will be same, but for instantaneous velocity, we will be using shorter intervals of time. Okay, but for average velocity, we will use longer intervals of time. We can use longer durations of time.
Sir, can you explain again? I didn't.
Okay, just 1 minute. So here we have to do acceleration. And in this, we have to do instantaneous velocity. Do instantaneous velocity and average velocity. So see, the instantaneous velocity is the velocity at a given instant of time. So for calculating the velocity at a given instant of time. So average velocity, it's total displacement over total time. Total displacement by
Then
total time.
yes,
Yes.
velocity will take the displacement and time of that instant.
Yeah.
Sir, for calculating instantaneous velocity will take the displacement and time at that given instant.
Yeah. At that instant. So it's like that. Suppose your vehicle is moving with somewhere at, I want to find out the speed at 9, 10 and 15 seconds. So it was at this instant I want to determine its time. Okay, so I will be determining, I will take a moment of around 1 second or maybe half a second. I will try to find out its position at say 9, 10, 9, 10 and 14. So at this interval, I will take its position. I will take its position as at 9, 10, 15, and then I will find out the speed. I'll find out the velocity. So that will give me the instantaneous velocity. Whereas if I want to find out the average velocity, so I will be using the total what is the displacement. I'll be using the total time, and then I can get the velocity, right? So these are the terms. Then acceleration, we had defined acceleration as the rate of change of velocity. Okay. We had done acceleration as rate of change of velocity. Rate of change of velocity as acceleration, right? So how fast the velocity changes, that we call as acceleration, and we can write acceleration as A equals V minus U over T. The symbols V and U there have their meanings. V represents final velocity and U represents initial velocity. U represents initial velocity and T represents time. So if I look up for the SI unit of acceleration, the SI unit of acceleration is meter per second square. SI unit of acceleration, it is meter per second square, ms minus 2, or we can write it as meters per second square like this also. So it is because since velocity is measured in meter per second, and meter per second divided by another second would give us meter per second square. Now let us do a few questions based on this acceleration. Based on the formula, we'll do certain questions. So let's try to attempt this.
Sir,
Yes.
so can we use SI unit of acceleration to find the acceleration?
You want to use the SI unit to find the acceleration.
Yes, yes, sir.
No, SI unit will be using it. See, it's like this. It's something like this. I think you want to know this. We see acceleration, we can write it as change of velocity will be measured in meter per second, right? ms minus 1, and time will be measured in second. So if you take the second on the top, it will become ms minus 2. That is meter per second square.
Okay, sir.
Okay. So were you asking the same thing or anything else?
Yes, sir, I was asking the same thing.
Okay. So see, the velocity and change of velocity, they will have the same unit. Like suppose if you have bananas, so you have 10 bananas, you ate 5 bananas. So I ask you change of banana. So what is the change of banana? That's 5 bananas only. The unit remains the same. If you find out the change, it's increment or decrement, so it is the same. Okay. Now let's see. Here we have a car moving with 90 km per hour. Spots a boy and decreases its speed to 36 km per hour in 3 seconds. Find the acceleration. So can you tell the acceleration now? You need to convert to SI units. So what is the initial velocity?
Sir, 90 km.
Yeah, 90 km per hour. So you'll write U equal to 90 km per hour. Then what is 36 km per hour?
Final velocity.
Final velocity V, which is 36 km per hour. And time is taken as 3 seconds. So we will convert this kilometer per hour into meter per second. How do we convert kilometer per hour to meter per second?
Sir, can we convert hour into second? Means like divided.
18 by 5.
5 by 18.
Okay. Listen.
It's 5 by 18. So 90 multiply 5 by 18, which is 25 meter per second. And 36 multiply 5 by 18.
Sir, it will be 10 meters per second.
Yeah, it is 10 meter per second. Then we can use the formula of acceleration.
Yes, sir.
Okay. So acceleration will be given as V minus U over T. So V is
Sir,
10.
in here we are getting the negative, right?
Yeah, we get here negative acceleration, right? And I had told you yesterday that if the speed will decrease, if the velocity decreases, then you will have a negative acceleration. We also call it as retardation.
Sir, can you repeat it down?
Retardation. I'm writing it down. Just 1 minute. So 10 minus 25 over 3, you will get 15 over 3, and 15 over 3 is 5 meter per second square, which is negative 5 meter per second square. So we also called this as retardation. We can say that it has a retardation of 5 meter per second square.
Sir, if it is in, we will convert it into kilometer per hour. Should we convert it again into kilometer per hour?
Where? No, it has to be in the SI units. Your final answer has to be in the SI units.
Okay.
Okay. So your final answer every time whenever you answer, so your final unit, final answer should be in the SI units as far as possible. Got it? So shall we do another question?
Yes, sir.
Yes, sir.
Okay, let's see another question here. See, so a stone is thrown vertically upward with a speed of or with a velocity of 19.6 meter per second. So if the acceleration, if the retardation, let me say, if the retardation due to gravity is 9.8 meter per second square. Okay. If the retardation is 9.8 meter per second square, find the time taken by the stone to reach the maximum height. So see here, the question is pretty clear. You are given all the values. You are given the initial velocity. So what is the initial velocity we have?
19.6.
19.6. So write here our initial velocity u as 19.6 meter per second square per second. And what is the acceleration?
Sir, 9.8 meters per second.
Yeah. So should we will be taking this acceleration as minus 9.8. See why we will take this as minus 9.8 meter per second square. First of all, the term retardation. Since it's written retardation, so that means it has to be negative. Or you can guess it even if it's written as acceleration. Then also you can guess it because when the ball is moving upward or when the stone is moving in the upward direction, so its speed is decreasing. We observe its velocity decreases. As it moves upward, its velocity will decrease. So therefore, the value of acceleration will be negative. Right? So we'll take here acceleration as minus 9.8, which is downward. You can also think of this way that since the ball is moving upward, but acceleration is downward, so both of them are opposite to each other. Okay. So we'll take acceleration as minus 9.8. Now, what is the final velocity? What should be the final velocity?
0.
How much?
Sir, will it be 0?
Yeah, it will be 0. When the ball reaches upward, its speed decreases. So there is a time at which this ball, there is a time at which this ball has a 0 velocity. So after that, it will not go up. From there, it will start falling downward. So at this point, it has its instantaneous velocity as 0. We will take its final velocity at this point to be 0. So final velocity will be 0. And now we want to find out the time. So find out the time now. Use the formula of acceleration and find out the time. Okay. So got the answer?
Sir, I have a doubt.
Yes. What is the doubt?
Sir, actually in the question you wrote, a stone is thrown vertically upwards with a velocity of 19.6, whereas in
19.6.
the, yes sir, whereas in the initial velocity you have written 19.8.
It's 19.6 only. It's double lighting over there. That's what you are getting confused. It's 19.6.
Where the time taken by the stone to reach maximum height is 2 seconds.
Yeah, at the maximum height, when it reaches the maximum height, its speed will become 0. Since as the ball moves upward, its speed is decreasing continuously. And if you
Sir,
decrease,
is the
yes,
answer 29.4?
no, the answer is not 29.4.
Where
The
is the
answer
Sir, is
is,
it
yes,
2 seconds?
2 seconds?
yeah, the
2
answer is
seconds.
2 seconds. Use the formula A equals V minus U by T. Put the
So
values,
we can,
yeah, put
sir,
your
I
minus,
took it in the equation and then I got v minus u by a is equals to t.
yeah, so you can get that way also. So V is 0 minus U is 19.6 divided by T. So your T we want to find out. You can transpose the terms. You will get here T equals to minus 19.6 divided by 9.8 minus. So you will get your answer as 2 seconds. Okay. So shall I give you another question?
Yes, sir.
So a car starting from rest has a uniform acceleration of 6 meter per second square. Find its velocity after 10 seconds of start. Can you find the velocity?
Sir, is it 6 meter per second?
How much?
6 meter per second.
6 meter per second. Isn't it 60 meter per second?
Yes, sir, 60 meters per second.
Use your formula. Your formula is acceleration equals to V minus U by T.
Where is the answer 60 meters per second?
Yeah, answer is 60 meter per second. You put acceleration as 10. equals, sorry, acceleration is 6. Put an acceleration as 6 equals V, we want to find out, minus U, which is 0 since it starts from rest, and time is 10 seconds. So just transpose, you get here 60 meter per second as V. Everyone is getting?
Yes, sir.
Okay, see. A bus moving with 60 km per hour applies brakes to stop the car or to stop the bus. Okay. Find the time taken to stop the bus if it takes, if the brakes can produce maximum acceleration the brake can produce maximum acceleration of minus 4.5 meter per second square. Okay, so this is the question. A bus moving with 60 km per hour applies brakes to stop the bus. Find the time taken to stop the bus if brakes can produce a maximum acceleration of minus 4.5 meter per second square. Okay, so who all have got the answer? Rohit, are you getting?
Sir, I'm not able to understand this question.
Okay, what are the things given in this question?
Sir, they gave us initial speed.
Hmm.
They gave us
So,
acceleration.
okay, what is the initial speed?
So 60 kilometers per hour.
We write here initial velocity as 60 km per hour. And what is the final velocity?
Sir, 60 into 5 by 18 will be the final.
Yeah, that we will do here. We will do 60 multiply 5 over 18.
Sir, I got it will be 16.67 if we round
Yeah,
it off.
yeah, you round it up, you get 60.6. So currently, if I keep it in fraction, it would be 50 by 3.
Yes, sir.
Okay, so let's keep it like this. We can do it into fraction also. That is also correct. Okay, so you get 60 km per hour. That is
Yes,
the
sir.
initial speed. Then we obtain the final speed. What is the final velocity?
Sir, it will be 60 minus 50 by 3 by time.
Just final velocity. See, the brakes are applied to stop the bus.
Yes, sir.
Okay, and when the bus stops, what would be its velocity?
Sir, minus 4.5 meters.
No, minus 4.5 meter per second square is something else. Akshara, Yeah, Akshara. Akshara, are you there? Okay, Harshit.
Sir, is it 0?
Yes, final velocity is 0. As finally the bus stops. The bus is stopped by the brakes. So the final velocity of the bus is 0
Sir, is the
meter per
answer
second.
75 seconds?
Yeah. You have the acceleration as minus 4.5.
Sir, is the
And now you
answer
can use the
75
formula of
seconds?
acceleration. 75 seconds you are getting.
Yes,
Okay,
sir.
just let's check it out. Okay, let's check it out. You get acceleration as v minus u over t. Then we get t as v minus u over a. Right? Your v or final velocity is 50 by 3 or 16.7 minus initial velocity is 0. Acceleration we are getting 4.5. So you get 16.7 divided by 4.5. Remove the decimal. This is your 167 over 45. So it is approximately 3 seconds. 3 point some seconds. Right?
Sir,
Yes?
the final velocity will be 0, no, sir?
Yeah, final velocity is 0. So that's what you have 167 divided by 45. And you get your answer as 3.71. So that is the answer, 3.7 seconds. You have there. Akshara, Jitendra,
Yes, sir.
Sir,
are
can
you
you
get?
roll up?
Yes,
Yes, sir.
Jitendra? Have you understood?
Yes, sir.
Okay. Yukta?
Sir, can you once roll
Yes,
up?
sir.
Okay, have you understood?
Yes, sir.
Okay, just now I will be giving one question. I will be checking everyone's answer.
Okay, sir.
Yes, Rohit, what happened?
Sir, can you once scroll up a bit?
Okay, this one.
No, sir, a bus moving one. I just want to go to the answer.
Where? The previous one.
No, sir, the bus one. The one which is the that one.
That was the calculator, no? Only page I had calculator.
Yes, sir.
These are the two pages. These are where I used the formula of acceleration, substituted the value
Yes, sir.
16.7 minus 0 over 4.5.
Okay, sir.
Okay, Akshara is not able to unmute. Fine, Akshara. So you will be all of you will be solving this small question. Try to solve it and give the answer as soon as possible. And your answer should be sent as a message only. Send your direct message. Do not send to everyone. Send the direct message so that I will get the question answer of everyone. So here you have the question. If you have understood the problem, then you will be able to solve it out. Okay. So a train starting from a platform attains a speed of 72 kilometer per hour in 5 minutes. Find the acceleration. So you have to find the acceleration. Starting from a stationary position, let it be. Let me clarify more. Your answer will not change. Yeah, Purjit.
Sir, do we convert 5 minutes into seconds?
Yes, you have to make all the conversions. Purjit, he has left. Okay, so till now I have not received any answers.
Sir, I have doubt.
Yeah, do it. I'm waiting for your
Sir,
answers.
how to convert 5 minutes into seconds?
So that 5 minutes is to be converted to second.
Yes, how to do it?
Okay, Sampath gave one of the answer. Rohit, your units are also incorrect, and maybe
Yes,
your
sir.
answer is also incorrect. Okay, your answer is also incorrect. Just anyway, we'll be solving it just now. I'm waiting. I'll wait another 1 minute for everyone's answer. Let me see. Okay, I got Yukta's answer also. Purujit, what about you? You can note down this question and solve it later, Purujit, right?
Okay.
So here, okay, now I'm solving, and you can check your mistakes wherever you went wrong. You can check it out. Okay, got one more answer from Rohit. Rohit Akshara. Okay, Akshara also gave answer. I think Akshara's answer is correct. Just 1 minute. Let's check. So let's check. We have here initial velocity as 0 since the train starts from rest position. Final velocity we have 72 km per hour. So this should be converted to meter per second. And 72 converted to meter per second would be 72 multiply 5 over 18. So you get here 20 meter per second. Now you just need to convert the time. So time is given as 5 minutes. And 1 minute equals 60 seconds. So 5 minutes would be equal to 300 seconds. So we have 5 minutes. This equal to 300 seconds. So we can use the formula of acceleration as v minus u over t. Our final velocity is 20 minus initial velocity 0 divided by time, which is 300. So we get 20 by 300. That is 2 by 30, which is 1 by 15. So now you can verify your answers. 1 by 15.
Sir, should we convert that 1 by 15 into meter per second square?
This
Sorry,
is no, this is no. Yeah, you can convert it to decimal. If you convert it to decimal, you get something 0.0667, right? So this should be your answer. Okay. So bye everyone. Do prepare for your test. See you again in next class.
Bye, sir. Thank you, sir.
Okay, bye.
Bye, sir. Thank you, sir.
Bye.